This is SpaceTime, Series 28, Episode 145, for broadcast on the 10th of December 2025. Coming up on SpaceTime, sugars, gum and stardust discovered in samples from the asteroid Bennu. New observations are showing how stars can defy a monster black hole at the centre of our galaxy. And a new radar technique may have solved a long-standing Martian mystery. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Regolith collected by NASA's Osiris Rex spacecraft during its sample return mission to the asteroid Bennu has revealed sugars essential for biology, a gum-like substance never seen before in astromaterials, and an unexpectedly high abundance of dust produced by supernova explosions. The findings, reported in 3 studies in the journals Nature Geoscience and Nature Astronomy, are providing new clues to scientists' biggest questions about the formation of the early solar system and the origins of life itself. The 490-metre-wide near-Earth asteroid Bennu orbits at an average distance of 225 million kilometres from the Earth and is listed as a potentially hazardous object. That means there's a slight chance that one day it could slam into the Earth. Scientists led by Yoshiro Furukawa from Takeda University found sugars essential for biology here on Earth in the Bennu samples. The 5-carbon sugar ribose, and for the first time in an extraterrestrial sample, 6-carbon glucose were found in the regolith. Although these sugars are not evidence of life itself, their detection, along with previous detections of amino acids, nucleobasetides, and carboxylic acids in Bennu samples, showed that the building blocks for biological molecules were widespread throughout the solar system. For life on Earth, the sugars deoxyribose and ribose are key building blocks for DNA and RNA respectively. Of course, DNA is the primary carrier of genetic information in cells. RNA performs numerous functions, and life as we know it couldn't exist without it. Ribose in RNA is used in the molecule's sugar phosphate backbone that connects a string of information-carrying nucleobases. Furukawa says all 5 nuclear bases used to construct both DNA and RNA, along with phosphates, have already been found in the Bennu samples, and these new discoveries of ribose mean that all of the components to form the molecules of RNA are present on Bennu. Of course, the discovery of ribose in an asteroid sample isn't a complete surprise. Ribose has previously been found in 2 meteorites recovered here on Earth. What is important about the Bennu samples is that the authors didn't find deoxyribose. This means ribose may have been more common than deoxyribose in environments in the early solar system. The authors think the presence of ribose and the lack of deoxyribose supports the RNA world hypothesis, where the first forms of life relied on RNA as the primary molecule to store information and to drive chemical reactions necessary for survival. Furukawa says that present-day life on Earth is based on a complex system organised primarily by 3 types of functional bipolymers: DNA, RNA and proteins. However, earlier life may have been much simpler. RNA is the leading candidate for the first functional biopolymer because it can store genetic information and can catalyse many biological reactions. The Bennu samples also contain one of the most common forms of food energy used by life on Earth. That's the sugar glucose, and that's the first evidence that an important energy source for life as we know it was also present in the early solar system. Meanwhile, a second study, this one led by Scott Sanford from NASA's Ames Research Center in California, Silicon Valley, and by Zach Gainsford from the University of California, Berkeley, have revealed a gum-like material in the Bennu samples never before seen in space rocks, something that could have helped set the stage on Earth for the ingredients of life to emerge. The surprising substance was likely formed in the early days of the solar system, as Bennu's young parent asteroid warmed. Once soft and flexible, but since hardened, this ancient, let's call it space gum, consists of polymer-like materials extremely rich in nitrogen and oxygen. These complex molecules could have provided some of the chemical precursors that help trigger life on Earth, and finding them in pristine samples from Bennu is important for scientists studying how life began and whether it exists beyond our planet. It's generally agreed that Bennu's ancestral asteroid formed from materials in the solar nebula, the rotating cloud of gas and dust that gave rise to our solar system. It contained a variety of minerals and ices. As Bennu's parent asteroid began to warm due to natural radiation, a compound called carbamate formed through a process involving ammonia and carbon dioxide. Carbamate is water-soluble, but it survived long enough to polymerize, reacting with itself and other molecules to form larger, more complex chains impervious to water. This suggests that it formed before the parent body warmed enough to become a water environment. Sanford says that with this strange substance, scientists are looking at quite possibly one of the earliest alterations of materials that occurred in this rock. Using an infrared microscope, Sanford's team selected unusual carbon-rich grains containing abundant nitrogen and oxygen. They then used X-ray spectroscopy to study the samples, finding something no one had ever seen before. Gainsforth says the team knew they had something remarkable the instant the images started to appear on the monitor. And they were consumed for months by the data and theories as they attempted to understand just what it was and how it could have come into existence. The evidence suggested that this strange substance had been deposited in layers on grains of ice and minerals present in the asteroid. It was flexible, similar to gum or soft plastic. The authors also noted that the strange material was translucent and exposure to radiation made it brittle. Its chemical makeup includes the kind of chemical groups that usually occur in polyurethane. But unlike polyurethane, which is an orderly polymer, this one has far more random connections and a composition of elements that differs from particle to particle. A third study, this one led by Ann Newen from NASA's Johnson Space Center in Houston, Texas, analyzed pre-solar grains, dust from stars predating our solar system. They were found in 2 different rock types in the Bennu samples, and they provide new information about where the parent body formed and how it was altered by geological processes. It's generally believed that pre-solar dust was well mixed as our solar system formed. But the Bennu samples had 6 times more of the supernova dust than any other studied astromaterial. And that suggested the asteroid's parent body must have formed in a region of the protoplanetary disk which was enriched by the dust of dying stars. The study also reveals that while Bennu's parent asteroid experienced extensive alteration by fluids, there were still pockets of less altered material within the samples which are offering new insights into its origin. Newen says these fragments retain a higher abundance of organic matter and pre-solar silicate grains, which are known to be easily destroyed by aqueous alteration in asteroids. Their preservation in the Bennu samples was a surprise, and it illustrates that some materials escaped alteration in the parent body. And this suggested the diversity of pre-solar materials in Bennu's parent body must have accreted as it was forming. By pursuing clues about what went on long ago deep inside an asteroid, astronomers can better understand the young solar system, revealing the precursors to and ingredients of life it contained and how far those raw materials may have been scattered thanks to asteroids like Bennu. NASA scientist and Osiris Rex co-investigator Daniel Galvin says the discovery of ribose and glucose in the Bennu samples could have major implications for the formation and evolution of life.
So Osiris Rex is NASA's first asteroid sample return mission. Launched in 2016, rendezvoused with asteroid Bennu in 2018, collected a sample from the surface of the asteroid in 2020, and then brought it back to Earth where it landed in Utah in 2023. And now this sample is available for scientists to study around the world to look for chemicals, and including the building blocks of life, which is what our team is interested in. So our team, which included an international group of scientists, discovered evidence for bioessential sugars, sugar molecules essential for life, in the samples returned from asteroid Bennu. We actually found 6 different sugars, including 2, ribose and glucose, that are fundamental for life as we know it. The reason that this discovery of ribose and glucose is so exciting is ribose is actually a fundamental component of nucleic acids. It forms the sugar phosphate backbone of RNA. Glucose is an important source of energy for all living organisms. And this is the first discovery of glucose in any astromaterial. So this is truly exciting, a very big surprise. We weren't expecting to find this in the Bennu samples. So in order to detect these sugars essential for life, we actually had to take some of the Bennu chips and crush them up. We made a powder, kind of like making flour. We used about 600 milligrams, so a fair amount of sample. And then we basically extracted it in water at cool temperatures, kind of like making a cold brew, a cold tea. And then extracted those sugars into that water. Then we analyzed the water by a technique called gas chromatography mass spectrometry, kind of a mouthful, but basically it allows you to separate the individual sugars and measure them and identify them by their masses. This discovery really builds on some of the earlier findings of the mission. When we first started the sample analysis, we discovered amino acids, in fact, 14 of the 20 protein amino acids found in life. And we also found the nucleobases. These are the components of the genetic code in DNA and RNA, all 5, in fact, and phosphates. So we had all the components that we needed to make proteins and enzymes, and almost all the components we needed to make RNA. We have the phosphate and the nucleobase, but not the sugar. And so this discovery of ribose was actually really critical. It filled in that missing component of this nucleic acid that some believe was really needed for the origin of life on Earth. Yeah, so what we're learning now with the discovery of all the 3 main components, the building blocks of life in the samples from Bennu, is that these actually formed very early on in the outer part of the solar system, 4.5 billion years ago. You had chemical reactions inside the asteroid Bennu parent body, this icy body with melting and fluid, salty brines that actually formed the sugars and some of these other building blocks of life. And then the parent body was flung into the inner solar system, into the asteroid belt, where it was eventually disrupted and reaccreted to have what we now have, asteroid Bennu, a rubble pile. What this means is that these building blocks of life were distributed from the outer solar system all the way into the inner solar system. They were everywhere, ubiquitous, which really makes me more optimistic that not only could these building blocks have enabled life on Earth, but potentially elsewhere, Mars, Europa, the outer solar system. I'm becoming much more optimistic that we may be able to find life beyond Earth, even in our own solar system. So I just want to make it clear that even though we found all of the chemical building blocks to make proteins and nucleic acids, we haven't found evidence for life itself in Bennu. We don't see nucleic acids or large polymers. And this actually opens up a whole new area of research. And the question is, why? Why didn't we have more chemistry leading to the origin of life happening inside this giant parent body? Did we not have enough time to form them? Were the temperatures too cold? What is the answer to that question? I think this is going to open up a lot of new areas of research for folks to try to figure out why didn't these building blocks advance to something more complex inside this giant asteroid parent body? So life, of course, requires the right environment, liquid water, energy sources, but it also requires these fundamental chemical building blocks. And we've already talked about the amino acids needed for proteins, the nucleobases, the genetic components of DNA and RNA, but also sugars, which can act as an energy source for life. We found all 3 of those in Bennu, and we've been looking for them in other asteroids and meteorites as well. So asteroid Ryugu, we have samples returned from that asteroid from the Japanese Hayabusa 2 mission, and we're looking for sugars in those samples right now. One of the challenges is that you need a lot more sample to analyze sugars. They're present at much lower concentrations than the amino acids and the nucleobases. And so with the Bennu samples, we've had the luxury of having more sample to work with to actually target these compounds. But right now, scientists are actively looking for these sugars in the Ryugu samples as well, and I wouldn't be surprised if we found them there as well. It's absolutely crucial that we return and bring back samples of pristine asteroid materials. We've got plenty of meteorites that we know are fragments of asteroids littered all over the Earth, but they get contaminated. The first thing that happens is a meteorite will come through the atmosphere and it'll be heated by atmospheric entry heating, potentially thermally destroying some of these fragile organic compounds. And then the meteorite hits the Earth and immediately it's contaminated by the soil, bacteria in the soil, organics, water, which could make it really hard to be able to discriminate between an organic organic compound that's a terrestrial contaminant versus an organic molecule that was actually formed in space. So having these pristine materials from asteroid Bennu and asteroid Ryugu is really a precious opportunity. We have these samples that were protected from the atmospheric entry, heating by the shield. They were contained in containers to protect them from the terrestrial environment. And so we know that these samples are clean from contamination. Bottom line is, with these pristine asteroid materials, we can trust the results. When we detect these sugars and other molecules, we know that they were formed in space and came from these samples and weren't a product of terrestrial contaminants from the Earth. So one of the biggest scientific mysteries is how we all came to be. How did life start on the Earth? And in order to answer that question, we go to these asteroids like asteroid Bennu and bring back samples to look for the chemical building blocks of life, to try to get clues into how life may have started on the Earth. Of course, with this new research, we've now found sugars, the missing component of the three that we need for life. So we have the amino acids, the nucleobases, and the sugars needed for proteins and nucleic acids. But I think what's really key here is that we're showing that these compounds were widespread throughout the early solar system, formed in the outer solar system, and then delivered to the inner planets, such as Earth and Mars. And so I think we're really beginning to understand that these chemical building blocks were not only ubiquitous, but were also delivered to environments on the early Earth and potentially other planets that would have enabled the origin of life. And for me, this is really exciting. It really makes me more optimistic that if life started elsewhere in this solar system, the building blocks were available to do it, and I think we're going to find it. So we found ribose in the Bennu samples, which is a really important finding because ribose is an important component of RNA as the sugar phosphate backbone. RNA, some have argued, was actually the first genetic material that started at the origin of life. It's called the RNA world hypothesis, and that DNA and the protein world followed subsequently. One of the interesting findings actually with the Bennu samples isn't what we found, but what we didn't find. We didn't find deoxyribose, which is the equivalent sugar in DNA that forms the backbone of DNA. Deoxyribose, we didn't see it above our detection limits, but ribose was present. So I think this supports this idea that maybe RNA did come first because there was more ribose available as its building block very early on. And perhaps DNA and deoxyribose did come later on in biological evolution. Some people consider the origin of life just a simple nucleic acid like RNA that could make copies of itself and transfer information that way. Didn't even require DNA or proteins or even a cell membrane. So this discovery of ribose, in fact, is really important and adds more credibility to that hypothesis that maybe the origin of life was just a single strand of RNA. One of the goals of the OREX mission was actually to study asteroid Bennu, which has been classified as a potentially hazardous asteroid because its orbit crosses Earth's orbit every now and again. And so the mission actually determined that the threat of impact of Bennu on Earth is very low. 0.037%, 1 in 2,700 chance of hitting the Earth in September of 2182. So well in the future. In fact, there's zero probability that Bennu will hit the Earth in the next 150 years. But the other aspect of this mission that was important was actually able to touch the asteroid to see what it feels like. During the sampling, we actually sunk in to asteroid Bennu, which was quite unexpected. We thought we were going to kind of springboard off the asteroid. So we learned just by touching it kind of how it was made up. But we also returned the samples. We have the samples in our lab to understand their physical and chemical properties. And all of this information is going to be really important for designing a mission if we ever have to deflect an asteroid like Bennu in the future so that it'll avoid colliding with the Earth.
That's Daniel Galvin, a NASA scientist with the Osiris Rex mission. And this is Space Time. Still to come, astronomers detect what appear to be numerous stars in stable orbits around Sagittarius A star, the supermassive black hole at the centre of our galaxy, and a new radar technique which may have solved a long-standing Martian mystery. All that and more still to come on Space Time. astronomers have detected what appear to be numerous stars in stable orbits around Sagittarius A star, the supermassive black hole at the centre of the Milky Way galaxy. The discovery, reported in the journal Astronomy and Astrophysics, defies earlier speculation that these objects are simply clouds of dust that would eventually be swallowed up by the black hole. Sagittarius A star is located roughly 27,000 light-years away. It's the centre point of our entire galaxy and has a mass of some 4.3 million times that of our Sun. The new observations were made using the new ARIS Enhanced Resolution Imager and Spectrograph mounted on the VLT, or Very Large Telescope, in Chile. The study focused on 4 of these unusual celestial bodies, which have been the subject of much discussion in recent years. Of special interest was the G2 cloud, long regarded as a pure dust and gas cloud. It was thought to have initially been elongated by the gravitational pull of Sagittarius A star, a process known as spaghettification. However, the specific observations made with ARIS, which captures radiation in the near-infrared range, show that G2 is on a stable orbit, and that suggests there must be a star hidden deep inside the cloud. The study's lead author, Florian Piska from the University of Cologne, says the findings confirm that the centre of the Milky Way is not only destructive, but can also be surprisingly stable. The new observations show that several so-called dusty objects are following stable orbits around Sagittarius A star. The binary star system D9, which Piska and colleagues discovered in 2024, also remains stable, despite the enormous gravitational tidal forces of the nearby black hole. In fact, it's the first known binary star system to be observed so close to any supermassive black hole. Now, in theory, the stars involved in D9 could merge to form a single more massive star due to the strong tidal forces. However, the ARIS data shows that so far D9 remains intact as a binary. And the same applies to other objects, such as X3 and X7, which also circle Sagittarius A star in stable orbits and are therefore far less fragile than earlier models had suggested. Piska says the fact that these objects are moving in such a stable manner, so close to a black hole, is fascinating. The results show that Sagittarius A star is far less destructive than previously thought. And this makes the centre of our Milky Way galaxy an ideal laboratory for studying the interactions between black holes and stars. This is SpaceTime. Still to come, a new study suggests an underground lake at the Martian South Pole ice cap may just have been a layer of rock and dust. And later in the science report, paleontologists have confirmed that anacondas have been giant snakes for over 12 million years. All that and more still to come on SpaceTime. A new study suggests that an underground lake beneath the Martian South Pole ice cap may be nothing more than a layer of rock and dust. The findings, reported in the journal Geophysical Research Letters, are based on new enhanced radar techniques employed by NASA's Mars Reconnaissance Orbiter spacecraft. The mysterious feature buried beneath thousands of metres of Martian ice was long suspected of being an underground liquid water lake. The 2018 discovery of this suspected lake set off a flurry of scientific activity as water is closely linked with life as we know it. While the latest findings indicate this feature is not a lake below the Martian surface after all, it does suggest that the same radar technique could be used to check for subsurface resources elsewhere on the red planet. So, how were these new observations made? Well, they were made by using the spacecraft to undertake a special manoeuvre which involved the vehicle rolling 120 degrees. Doing so enhanced the power of the radio signal, allowing it to penetrate deeper underground and provide a clearer image of the subsurface. The study's authors, Gareth Morgan and Than Putzig from the Planetary Science Institute, had made multiple unsuccessful attempts to observe the area of the South Pole suspected of hosting this mythical buried lake. But they then partnered with the Mars Reconnaissance Orbiter's operations team at NASA's Jet Propulsion Laboratory in Pasadena, California, to develop a very large roll capability. Because the radar's antenna is at the back of the orbiter, its body obstructs its view, and therefore weakens the instrument's sensitivity. After considerable work, engineers at JPL and at Lockheed Martin, which built the spacecraft, developed a set of commands which allowed a 120-degree roll to take place. a technique that requires careful planning to keep the spacecraft safe, but which directs more of the radar signal down to the surface. On May the 26th, the orbiter performed a very large roll to finally pick up the signal at the target area, which spans some 20 kilometres and is buried deep below a slab of water ice almost 1.5 kilometres thick. When a radar signal bounces off underground layers, the strength of its reflection depends on what the subsurface is made of. Most materials let the signal slip through or absorb it, making the return faint. Liquid water, however, has special properties, and it produces a very reflective surface, sending back a very strong signal. And that's the kind of signal that was spotted from this area back in 2018 by the European Space Agency's Mars Express orbiter. To explain how such a body of water could remain liquid under all that ice, scientists had hypothesized that it could be a briny lake, since high salt content can lower water's freezing temperature. Putzig says the team had been observing the area for almost 20 years without seeing anything. But once the Mars Reconnaissance Orbiter achieved a very large roll over the precise area, the team were able to look much deeper. And rather than the bright signal ESA received, the Mars Reconnaissance Orbiter only detected a faint one. The Martian South Pole has an ice cap sitting on top of heavily cratered terrain, and most radar images of the area below the ice show lots of peaks and valleys. Morgan and Putzig say it's possible that the bright signal detected here may simply have been a rather smooth area, such as an ancient lava flow. The authors now want to use this same roll technique to re-examine other scientifically interesting regions of Mars, such as Medusa Fossae, a sprawling geological formation on the equator that produces very little radar return. While some scientists have suggested that it's composed of layers of volcanic ash, others think those layers may include heaps of water ice beneath. Needless to say, we'll keep you informed. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that the risk of dementia increases with any level of alcohol consumption. The findings, reported in the British medical journal Evidence-Based Medicine, represent the largest observational and genetic study of its kind undertaken so far. Scientists used observational data from over 500,000 American and British adults, looking at both drinking and dementia outcomes, as well as genetic data from 2.4 million people in order to examine the association between dementia and genetic risks for alcohol use. While the observational study suggested high dementia rates among non-drinkers as well as heavy drinkers, the genetic analysis showed dementia risk increases with alcohol intake. The authors say the apparent protective effects of light drinking, which have also been reported in previous studies, could be partly due to people with dementia cutting down on drinking, and that reducing alcohol intake could be an important dementia prevention strategy. Paleontologists have confirmed that anacondas have been giant snakes for well over 12 million years. The new findings, reported in the journal Vertebrate Paleontology, are based on detailed analyses of fossil remains of 183 ancient anaconda backbones, representing at least 32 snakes in Venezuela. They found that these snakes were some 5.2 meters long, matching the size of anacondas today. While other giant animals, such as the 12-meter caiman and the 3.2-meter giant freshwater turtle, long since gone extinct, anacondas appear to have bucked this trend and survived as a giant species. A new study has confirmed that chatting with an artificial intelligence bot programmed to advocate for a specific political candidate can help influence a voter's behaviour. A report in the journal Nature tested an AI model on willing participants during national elections in the United States, Canada and Poland during 2024 and 25. The authors say their model was instructed to be positive, respectful and fact-focused, and voters were randomly matched to chat either with a bot that supported their original voting intentions or supported the opposite candidate. The authors say the chatbot was able to strengthen the participants' views, but it appeared to be even more effective at persuading people initially opposed to a specific candidate. They say the bot's fact-based arguments were more effective than discussions of personality traits. However, the AI didn't always present accurate facts, even though it was instructed to be truthful. The Australian Albanese government's new social media ban on children, which are being used to try to force people to use digital ID, are already causing a set of spin-off scams. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Some social media platforms are going to be restricted by law, as we've been discussing, to people aged 16 and over. These platforms have to take reasonable steps to prevent anyone under 16 from creating and holding accounts. And there's going to be some scams. ScamWatch, which is Australia's national scam alerting site run by the government, they've identified 4 potential scams that opportunistic criminals may use to take advantage of these changes. Obviously, it's young people and their families that are at risk. The scams could look like platform impersonation scams. They may pretend to be social media platforms or age verification providers and ask you to verify your age or risk losing your account. Then there's government impersonation scams where they may pretend to be the government or law enforcement, claiming you have breached the new laws and threatening fines unless you provide proof of age. The third is fake ID scams. Scammers may offer fake IDs or access to age-verified accounts for a fee, targeting young people under 16 and their families. And there's also the well-known Hi Mum scams where they might impersonate young people aged 16 or older, contacting their parents or guardians to come in and help verify their age to use a social media platform. So if the old stop really thinks, is this real? Can I go to the ScamWatch site or can I go to the website of the social media platform and check that I'm properly verified to use that service or whether they're sending these sorts of things out? So stop and check and protect your personal information. It's amazing how many people will give personal information out just because somebody's asked for it. So be cautious and don't trust anything or anyone. Simple as that.
That's Alex Zaharov-Reutt from TechAdvice.life. And this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.